Hello everyone, class 12th. The topic name is allylic chlorination. Before understanding this topic, we need to understand allylic carbon. sp3 hybridized carbon, if it is connecting with doubly bonded carbons, alkene carbons, so this carbon is known as allylic carbon. Now if this carbon have hydrogens on it and we are going to react it with chlorine in high temperature, so one chlorine atom will substitute one of its hydrogen. Allylic carbon hydrogen will be substituted by chlorine. So next product will be this. Valencies you can satisfy with the help of hydrogens. Side product, one chlorine atom is joined with carbon and hydrogen is substituted. That substituted hydrogen will react with another chlorine atom and HCl will be the side product. This is known as allylic chlorination. Suppose we have this reaction in front of us. We have to find whether we have allylic condition or not. Yes, we have allylic condition here. This carbon is sp3 hybridized, which is directly connected to doubly bonded carbons. So this carbon is allylic carbon. Hydrogens are present over there and we are going to react it with chlorine. If temperature is high, for allylic chlorination, high temperature is required. One hydrogen will be substituted and side product will be HCl. Such reactions are known as allylic chlorination, always happens on high temperature. Let's check the mechanism of it. Mechanism of allylic chlorination. It is happening through free radical mechanism. And I told you free radical mechanism happen in 3 steps. Step number 1, chain initiation. Start of the reaction. At high temperature, the chlorine molecule will break like this and chlorine free radicals will generate. These are chlorine free radicals. One unpair unused electron they have. Second step is chain propagation, in which products will generate. Now we know we are using allylic carbon, so I have written over here allylic carbon. Now in this step, this allylic compound will react with one of the carbon free radical. Now this chlorine free radical will attack on hydrogen and bond breakage will happen. This is first propagation step. And HCl will generate out as a side product and new carbon free radical will generate. This is known as allyl free radical. In chain propagation step, this is first step. Now second step will be This allyl free radical will attack on another molecule of chlorine, and chlorine molecule will dissociate like it. This unpaired electron will make bond with this chlorine unpaired electron, and products will be this chlorine is joined with this carbon, and this chlorine will generate out as chlorine free radical. Now what this chlorine free radical will do? It will repeat the whole cycle again, and another new free radical will generate. That chlorine free radical will again repeat the whole cycle, and then again new free radical of chlorine will generate, and in this process the chain will continuously move like this. And what we are getting during this whole product, this whole process, this main product, in which you can see the hydrogen is substituted by chlorine, and which hydrogen? Allylic hydrogen is substituted by chlorine, and side product is generated over here, HCl. Now after chain propagation step, the last step we know, chain termination step. Third step, chain termination, means those steps which are trying to stop the reaction. Suppose two chlorine free radical combines back and create chlorine molecule. So this step is trying to stop the process, because for free radical mechanism, continuous generation of continuous generation of free radical is important. If any reaction is not making new free radical, so those reactions will be categorized as chain termination reactions. One is this. Another possibility is this. If allyl free radical and chlorine free radical combines together, this one, no new free radical is generated. So this reaction is also categorized in chain termination step. Third, two allyl free radicals can combine to create, if you will join, then you will find out. Like this molecule. So all these three reactions are trying to stop the process, because in all these three reactions no new free radical is generated. In chain propagation step, you can check after every step a new free radical is generated which is reacting further, and new free radical is generated which is reacting back. Means like first free radical is finishing, it is creating new free radical, that new free radical is reacting further and it is creating new free radical. The chain will be propagated, but in these steps you can find no new free radical is generated. That's why we are calling them chain termination step. Now one important point. Why allylic carbon free radical is preferred by chlorine? If we are doing chlorination of it, let's write all possibilities. The first possibility is this hydrogen if is getting substituted. So what free radical will generate out here? This one. If this hydrogen is getting substituted, this one, so what free radical will generate out? This free radical. And out of these three hydrogen, if free radical, if hydrogen is substituted, then this free radical will generate out. Our reaction is preferring this free radical because you can check chlorine is joined over here, not on this carbon, not on this carbon. The reason is high stability of allylic free radical, carbon free radical. It is highly stable as compared to these two. Now, which factor is making it so much stable? That factor is resonance. Due to resonance, there is a movement of unpaired electron. One time it is on this carbon, after resonance, it will be on this carbon. And again next time it will be on this carbon. So continuous movement of unpaired electron will be there, due to which it is getting a stability. Let's write that resonance. A resonance is like this. One unpaired electron will come here and unpaired electron of this carbon will come here, and they will make covalent bond with each other, due to which next molecule will be this unpaired electron will go to this carbon. This will be the next molecule. And again this will go to this, and from here again unpaired electron will come to make bond over here, and same structure will generate, same molecule will generate. This process will be continued. Here, like in this case, carbon have one unpaired electron. In next structure, this carbon have one unpaired electron. This process will be continued there. This we call resonance, the movement of unpaired electron, due to which the molecule is getting stability. This process is not possible in other free radicals which were generated, which I have written. That's why this free radical is extra stable as compared to those free radicals, and that's why reaction is preferring to make this free radical, and the final product is according to this free radical. So that's it. This is the end of allylic chlorination. One more reactant you can use for allylic chlorination also. Suppose we have allylic carbon over there, SO2Cl2, sulfuryl chloride. This reagent we can also use for allylic chlorination. Side products will be sulfur dioxide gas and HCl gas. And at the place of allylic hydrogen, we will have one chlorine atom over there. Mechanism is same. Free radical mechanism is happening over there. Thank you very much for watching the video.